All right, in this video, we are going to be talking about writing quadratic equations in vertex form. There's actually several different ways to write quadratic equations. Just like one of the ways that we can write a linear equation is with y equals mx plus b, or we call that slope-intercept form. There's three main ways to write quadratic equations. The first one that we're going to talk about in this video is using vertex form. And there's two others, factored form and standard form, and we're going to talk about those in later videos. So just in vertex form, in this one, just like there is like a linear function, could be y equals mx plus b, that's kind of like the general form of it. And this one, the general form for vertex form looks like this. And these different letters mean different things. The A is, it's kind of like the slope. It determines like how steep the U shape is, if it's like really skinny or if it's like really spread out. And that is, we get that from taking half of the second change. So remember in the first video, we found the second change, like we found the first change, like, oh, it's not constant, must not be linear. Then we found the change of the changes. Whatever that number was, you take half of that, and that's the A value. We're going to practice doing that in a later video also, but for right now, I'm just going to give the A value so you don't have to worry about finding it. And then, so that's what you would plug in for this number right there, is the A. Now the other two letters that we see here are H and K, and what those are, those two make up the coordinates of the vertex. So whatever the vertex is, the x-coordinate of the vertex goes there where the H is, and the y-coordinate of the vertex goes there where the K is. This x just stays an x. That doesn't change. Just like in y equals mx plus b, the x just stays there. That's the independent variable. That just stays there. So let's practice. So let's say you have a parabola, a quadratic function, and the a value is 2, and the vertex is at 4, 3. So if we were going to write this function, we'd start with f of x equals, and then we'd write the a, which we said was 2. And then we have a parenthesis, x just stays x, and it's x minus the x-coordinate of the vertex, which in this case is 4. So we're going to say x minus 4 squared plus k, and k is the y-coordinate of the vertex, which is 3. The squared is really important. That's what makes it a quadratic function. Quadratic functions are functions that have a squared in them as the biggest exponent, and so you need that squared. If you don't have the squared, it just goes right back to being a linear function. So make sure that you don't forget the squared up there. Let's look at this one. We have f of x equals, now the a value is 1, so we'll write 1. And then x minus the x-coordinate of the vertex, which is 3. So x minus 3 squared. And the y-coordinate of the vertex is negative 1. So out here for the k value, we'll write minus 1. Now, when you multiply something by 1, it doesn't change. So another way that you could write this is you could just say f of x equals, and then you could just skip the 1 and say x minus 3 squared minus 1. These are the same thing, because if you times it by 1 or you don't times it by 1, nothing changes. So if you see that there's no a there, that just means that the a value is 1. Let's look at this next one. Notice that the a value is negative 2. That is what flips it upside down to make it a negative, or to make it an upside down u, or to make it open down. If the a value is negative, it makes the function open down. So for our a value, we'll write negative 2, because that's the a value. X minus the x coordinate, which is 2, so I'm going to write x minus 2 squared. And then the y coordinate is 3, so I'll write plus 3. Now if we look at this one, the a value is 3. So I'll write f of x equals 3. Now I'm going to write x minus the x coordinate, which is negative 2. So I actually have x minus a negative 2 squared plus 1. Now we know that if we're subtracting a negative number, that's really the same as adding. So we can also write this, and this is probably the better way to write this, as f of x equals 3, and then instead of x minus a negative 2, we'll say x plus 2 squared plus 1. So what ends up happening, if you notice, whatever is here, the negative 4, negative 3, negative 2, and then down here it ends up looking like a plus 2. Really, because of that negative that's part of the equation, is really just the opposite of what the x-coordinate is. So here, the x-coordinate is a 4 of the vertex. Over here, we see minus 4. Here, it's a 3. Over here, we see minus 3. Here, it's a 2, minus 2. Here, it's a negative 2. So in our final equation, it's a plus 2. The x-coordinate ends up looking like the opposite of what the x-coordinate of the vertex actually is. The y-coordinate just stays the same, positive 3, negative 1, 3, 3, 1, 1. So let's take that information and really quickly just look at each equation and just kind of pick out, by looking at the equation, where the vertex of this would fall. If we were to graph it, where would the vertex be? So this first one, it's going to look like the opposite of that. So if that says minus 2, we know that the x-coordinate of the vertex is actually a positive 2, and the y-coordinate is 5. Here, because that's a plus 3, the x-coordinate is actually a negative 3, and the y-coordinate is negative 1. The x-coordinate is always opposite. Really, that's like x minus a negative 3, but we just write that as x plus 3. Here, it's like x minus a negative 4, so it would be negative 4, 2, and then down here, it would be 3, negative 2. All right, and that is how you write functions in vertex form, and that's how you can use vertex form functions to find the vertex. Each of these 3 different ways to write it gives us information about the function, and vertex form actually gives you information about the vertex. Go figure. So go ahead and try the practice. If you have any questions, feel free to email me. Otherwise, the practice is in Google Classroom. Thanks.